Hey everybody, welcome back to another fun and exciting pre-calculus class. In today's lesson, we are going to be continuing in chapter number 15. We'll be doing lesson 2 today. This is a very different lesson. I've never taught like this in this pre-calculus class. So yeah, let's see what happens. So we'll see how this turns out. Hopefully you'll like it, and hopefully it'll be something that you're able to do without too much trouble. This is basically going to be a calculator tutorial. All right, so let's jump into it. Here we are on page 297 in your book, page 297. We have the method of least squares, general equations, and data fitting nonlinear data. That's a big title, and you know it's a big bunch of information here. So let's go ahead and take a look at it and see what we need to do here. So just from like the last lesson, we talked about how we fit this data into a linear equation. We used slope-intercept form, y equals mx plus b. So here it is again, y equals mx plus b. Now, the problem is that sometimes the data doesn't really kind of match up to this. So we kind of have to, I guess in a way, like force it into the equation, if you will. So what we do here is basically, I'm not going to go through this whole delineation, but we basically take all this information and we put it into the form, and we end up with a bunch of different numbers from like, okay, so this happened once, twice, 3 times. If you look, so you have this happening once, it happens twice, 3 times, and then it goes x to the n. What is x to the n? X sub n means that it happens n times. N times means any number of times. So this could be happening 27 times. This could be happening 50 times. This could be happening 1,000,000 times. When it's a sub n, that means that it's to any variable. Okay, so any number that we're going to, and every situation is going to be different. Like every event, everything that you're graphing is going to have a different number of values. Okay, so that's why it just goes x to the n and y to the n. Now, mathematical notation, and now you should know this, first of all. This was taught in the Algebra 2 book, but if you either didn't have Abeka for Algebra 2, or maybe you just forgot, because that happens, right? So let's go through this really quick. Mathematical notation called summation notation is used to replace lengthy and awkward sums. So instead of adding y sub 1, y sub 2, y sub 3, and so on until y sub 53, all right? We write that like this. This is a sigma, okay? This is a capital letter sigma. It's a Greek letter. The I1 is what's called the lower bound. That's where we're starting our counting at. And then the upper bound, this n up here, is where we stop counting, okay? So I don't know if you can see that there, but this n. So hopefully you have your book, and I know it might be a little bit difficult to see that little n on top of the sigma right there, but it's there. That n always changes based on how many values you have in your list. So, you know, however many you have in your list, that n is going to change, that upper boundary. So what is this? This is counting a bunch of sums. It's counting the x1 plus the x2 plus the x3, and it's counting all the way up. Now, I know it looks a little bit weird. There's a lot of different sigmas and all kinds of different things, but check out what's going on here. If you'll look at this, they're kind of putting this into the y equals mx plus b. All right, so we're fitting these sums into the slope-intercept form, y equals mx plus b. Now, let's go ahead and turn the other page, and let's look over here on page 298. Once we've kind of done that, now once we collect the data, it doesn't always like kind of fit into the linear, right? So we talked about that. One way that we can kind of work with this information is by using the Pearson R correlation coefficient. All right, so what is that? This is what's called the R value, okay, of these. So when you're in statistics, you'll hear the R value every once in a while. So what is the R value? Here's what it is. It's this formula right here. So if we take R equals, and here's a sum. Okay, so this is n. What is n? That's the number of values you're dealing with. And then you have this times the sum of xy. All right, now this is just a little bit tricky right here. So this is the sum of xy. This does not mean the sum of x times the sum of y. This means the sum of xy. So look down here in this chart that we're going to build out here. So xy is basically taking these x values times the y values. So here we have the xy column, and so we took 0 times 6. Why? Because 0 times 6. This is the column that would go right up here in this first place, the sum of this column. So you're not multiplying the sum. This right here, so we'll subtract, this right here is the sum of x times the sum of y. All right, what does that look like? The sum of x, so doing the x column, summing that up, summing up the y column, and then you'll multiply those two things together, okay? And so that's the difference between those two things. It's very important to understand that, because I see a lot of students mess up there. They think, oh, this is multiplying together. No, it's not. It's the sum of the xy column, the xy column right here. And we'll get to that chart in just a little bit. Then on the bottom, we're going to take the square root of this whole thing down here, this whole denominator. What is this? This is n times the sum of the x squared column. Okay, so there's our x squared column, and then it's subtracted by the sum of the x column squared. Again, you have to understand these things. So this is the x squared column, okay, this one here, x squared column. This is the square of the sum of the x column. So this column over here, we're going to square this number, basically. So there's a big difference between those two things. You have to do what it's telling you to do. The chart's going to be the key. You're going to see where we're going to build out the chart here in just a second. And then everything just slides into this formula. Then you have the n times the sum of the y squared column minus the sum of the y column squared. Okay, so make sure that you know that formula. Write that formula down. I say know that formula. You at least need to have it written down. You need to know how to use that formula for sure. All right, so here's our question. Calculate the Pearson R. So then we're going to, here's the information from our chart. Well, you could actually do this whole thing if you wanted to, and you could write this whole chart out if you felt like it. I mean, if you feel like doing that, that is great, but I'm going to show you a big time shortcut right here. So if you see this this note down here, it says to avoid rounding errors, use calculator memories to store lengthy sums. I'm going to show you how to do that. Maybe you already know how, and that's awesome, but I'm going to show you how to do it. So let's save some time, and we don't have to sum this whole thing up. Let's take a look at this. So here's my calculator, and we're going to put the x and the y values in the calculator. So we're going to go here, and we're going to go to, now everybody's calculator is different. This is just the one I'm using. I'm using the Casio FX 300 ES Plus, second edition, okay? So everybody's calculator is going to be a little bit different. Texas Instrument has a much different way of doing it than the Casio has. So you're just going to have to learn what your calculator does. So for me, I'm going to go to mode, and I'm going to turn it into stat mode. So I need to hit the number 2. Now, once I hit the number 2, I want to come over here to 2 again, because we have an A and a B. We have an X and a Y. We have a T and a D. We have 2 variables, okay? So I'm going to hit 2 again. This is going to give me a 2 variable table, okay? So here's my table, and now I want to put in all of my X values. So I'm going to go ahead and put in 0. That's my first X, and then I'm going to hit enter or equals, and that's going to populate. Now, it's also populating the Y column. Don't worry about that right now, okay? We're just going to put in the X. So then we have 5, enter, 10, enter, 15 equals, and I'm hitting enter on my keyboard because it's connected, but I'll show you doing here 20 equals. Equals puts it into its place. So 25, it's just easier for me to hit enter, and then 30. Okay, so we have all of our values in now. So we have 7 values put in there. Now what you want to do is use the arrow key and arrow over to y1. And now we need to input y1, which is 6. And then we're going to input y2, which is 6.6. And then y3, which is 7. And then 7.40. And then 7.92. And then 8.6. And then 9.1. All right, and there's our table. Our table is now built out here, and you can go back up and look through it and scroll back and forth between the X and the Y. Okay, so that's the first part. Let's set up our table in the calculator. Now again, this is where everybody's calculator is different. On mine, you have to clear it out. Okay, so you're all worried like, oh no, where'd our table go? No, it's in the memory. Don't worry about it. Okay, so it's in there, and you're gonna have to figure out how yours works. Now I come over here to hit Shift 1, which is stat. Okay, Shift 1 gives me my stats. Now I'm doing sum, right? That's what I want to do. I want to add everything up. So I need to do my sum. So I'm going to hit 3. And now it asks me what sum do I want. So I want all of these different sums. So I want the sum of the X, right? So that's this one right here. So that's going to be 2. So I'll hit 2 and then equals 105. There we go. Bingo. Now this is the reason why we put it into the calculator like this, so we don't have to keep redoing it every time. The calculator just keeps remembering what we're trying to do here. So we're going to do sum now of the Y column and hit enter. And there's our 52.62, okay? So now you're just writing these down. You're not even writing the chart. You're just writing the sums of these different things down. And you do need to write these down. You may have a calculator that can store multiple sums. That would be awesome. Or you might not. So clear this one out, Shift 1 again, and I'm going to do sum again. Now I'm going to do the X squared column. I'll move this over here so that you can see the X squared column. And so that's going to be the 1, and then hit equals, and then 2275. Okay, 2275. We're going to clear it out again. Now we're going to do the Y squared column, and that's number 3. And then that equals 402.8164. There we go. And then we'll clear it out one more time, and then we'll do it once more. So Shift 1, and we want number 3, and this time we want this one, the XY number 5, right? So we want to hit 5 equals 860.4, 860.4. There it is. All right, now that we have everything kind of written down, here's what you're going to do. You're going to sub all of this information in right here back into this formula up here, this Pearson R formula. Okay, so turn the page, and here it is. There's the formula. There's the sub into the formula. It's possible that you have a calculator that can do the Pearson R. You don't even have to really kind of sub in anything like that. So you might want to look into your calculator. It's possible that you don't even have to do this, but most calculators don't have that Pearson R, so you will have to, manually enter all this stuff in. But you can enter it in your calculator, and you can do it all at one time. I have found that it's probably best to do the square root first, and then do this, and then do the division. So sometimes when you're trying to enter this much information, this whole equation into your calculator, it may get a little bit dicey for you. So you can try, and who knows, it might work out just fine. Okay, so now once you have the R right here, notice it says this indicates a strong linear relationship, continued regression analysis. It's possible that if you get if your number is way far away from 1, so if it's like 0.09, it's going to be the thing is going to be so spread out, it's not worth doing it. And there's some information here on this previous page. So values close to either -1 or 1 indicate very close to a straight line. So since we're very close to 1, that's going to work. Values close to 0 indicate no correlation, and so you might as well not even keep going with it. But so here we are. We have this. Now notice it shows an M and a B. We need our M and our B for our equation, right? Well, where do we get that? Well, I kind of skipped over this real quick because I was going to come back to it and I didn't want to get you confused right there. So notice at the bottom of page 297, it gives you the formula for your M and it gives you your formula for your B. So now you have to find your M and your B. Plug into those formulas. It works the same exact way as the Pearson R. You just plug in the values. So once you get your values from your table, plug them into the M and the B, and then you will have the three things that you need. You need your R to know if it's actually going to work. And again, if it's close to 1 or -1, it will work. If it's close to 0, it's not going to work. So then you go ahead and plug in, get your M, get your B, and now you can plug this into your formula. What is this? This is Y. Okay, I know it's a D, but this is Y equals, notice we're using bacon here. Why are we using bacon? Because it's approximately equal to. Why is it approximately equal to? Because we've rounded off. There's rounding going on here. So this is Y equals M. So here's your M, here's your X, and here's your B. Okay, and that's your formula for your line of fit, your best line of fit that you can have. Now, one more thing that I kind of need to teach you real quick so that you can do this type of problem is when you have data fitting of nonlinear data. So in other words, it's exponential data. This data has exponents in it, right? So since we use y equals mx plus b, we use a line, we're going to need to figure this out. How can we get exponential data to go into a line? Well, the way that you do that is, well, let's start with this. What is the opposite of exponents? Okay, what's the opposite? Do you remember? The opposite of an exponent, again, this is Algebra 2 material. The opposite of an exponent is a logarithm. Okay, so the way that we do that is we basically take the log of everything. So y equals axt becomes log of y equals log of a and xt. Now, you use your logarithmic properties, also your exponential properties, to say, okay, when we have exponents, we're actually adding our exponents when we're multiplying. So we're multiplying here, so we're going to be adding our exponents. So now is where you kind of see that come out, where you have y. Yes, it's log y, but this is still your y. And here's your mx over here. So t log of x, and then plus b. So y equals mx plus b. Okay, so you use the log. Now here's the natural log. When do you use natural log? When you have an e. What is e? Euler's number, Euler's number, however you say that. When you use this number, this e, you actually use the natural log, because the opposite of Euler's number is actually ln, or natural log. So you got the same thing. Once you do that, apply your exponential properties, you get y equals mx plus b. Let me show you how that looks in our formula here. So we're going to, here's our chart, okay? And so here's our information. Now, because of this, we're using P equals AVT. This is basically they're going to give you that. That's the formula they're going to give you. And we need to compare this, or we need to fit this into y equals mx plus b. The way that we do that is we multiply log by everything. Make sure that you separate or you expand your log right here. And then you have log P equals log A plus T log V. So that's basically right here, y equals mx plus b, or in this case, y equals tx plus a. It's just using the letters that they gave you. Now, all you do is you do the same thing in your calculator, and you can do this on your calculator. I'm not going to take the time to show you how to do it, but you can do it. It's the same thing. It's the same sum notation, right? So you do all this, you log 50, you actually type that into your calculator, it'll give you a sum, and then you just kind of do all these different things, make your charts. Your n is 7 again. Why is n 7? Let's go over that real quick just in case you forget. Because there's 7 values. Look, 1 value, 2 values, 3 values, 4 values, 5 values, 6 values, 7 values. So y is 7. There are 7 values. So, just kind of go down here and get your information, plug it in, and then you'd have to go back and get your M, and then go back and get your B, and then you would finish it off by just kind of plugging everything into it. Now, the interesting thing about this is that once you get y equals mx plus b, basically, once you kind of put it into that format, now you're going to re-put it into the exponential form. So you're going, that was in log form, now you're putting it back. That's what this is right here. That's kind of multiplying everything by the exponent or by the log. You're putting it back into logarithmic form. Again, those are Algebra 2 things. I'm not going to spend a ton of time on that, but you should be able to do that. If you can't, then make sure that you kind of work through or look through these examples and try to figure out how exactly they're doing that. But it's not too difficult. You just kind of multiply log by everything and it just goes back. So you're just kind of redoing what you did in the first place when you multiplied everything by ln or everything by log. All right, well, hey, there it was. I told you it was going to be different. I did not even go to my computer screen at all. We just kind of went through the book right there. So that was a calculator tutorial. Hopefully hopefully you knew a lot of that stuff, right? Because it's all stuff that maybe you've gone over before in the past and it was just a refresher. Hopefully you were using your calculator, figure those things out. This is just going to be a lesson where you're just going to have to just work through it. You might have to look up tutorials or your owner's manual online. They usually have a PDF. Type in your calculator type or go to YouTube. I know Casio has like all of their stuff on YouTube, like all of their functions and things, like how to use them. There's like an official channel for Casio. Texas Instrument probably has the same thing. Whoever you're using for a calculator, you should be able to find some help there online. So that's all I've got for you. If you missed anything, slide it back and just work on this, practice this stuff, and you need to practice to get good at it, okay? That's all I've got. We'll see you later. Have a good one. Bye-bye.